The Messerschmitt Me-262 emerged from a period of intense innovation and strategic desperation in the later stages of the Second World War. By the late 1930s, aviation engineers in Germany were already exploring the potential of jet propulsion, seeking to overcome the limitations of piston engine fighters whose performance gains were beginning to plateau. The Reich Air Ministry, RLM, recognized the promise of jet-powered aircraft for both speed and altitude advantage. But the project initially progressed slowly due to the novelty of the technology, resource limitations, and shifting political priorities. The Me-262's origins can be traced to 1938, when Messerschmitt engineers, under the direction of chief designer Waldemar Voigt, and with oversight from Willy Messerschmitt himself, began conceptual work on a jet fighter that could outperform any contemporary aircraft. Early designs, known internally as Project 1065, envisioned a streamlined airframe with twin engines mounted beneath the wings. The challenge lay in developing suitable jet engines, a task entrusted to BMW and later Junkers, which were experimenting with axial flow turbojet designs. The strategic rationale for the Me-262 was clear. Germany needed an aircraft capable of countering the growing Allied air superiority. By 1942, Allied heavy bombers were penetrating deeper into the Reich, and conventional Luftwaffe interceptors were suffering heavy losses. A jet fighter with unprecedented speed, capable of exceeding 800 kilometers per hour, promised to close the performance gap, disrupt Allied bombing campaigns, and restore some measure of control to the German skies. However, bureaucratic obstacles, technical setbacks, and Adolf Hitler's shifting directives, including his preference for adapting the aircraft as a fighter bomber, delayed the project's pace at critical moments. The conceptual breakthroughs of the Me-262 lay not only in its propulsion system but also in its aerodynamic design. The aircraft featured slightly swept wings, which reduced drag at higher speeds, and tricycle landing gear, which was unusual for German fighters of the era, but offered superior handling during takeoff and landing. These features, combined with a nose-mounted armament of four 30mm Mk108 cannons, were tailored to deliver devastating firepower against Allied bombers. Still, every advantage came with challenges. Jet engines of the period were fragile, fuel-hungry, and prone to short service lives, often requiring replacement after just 10 to 25 operational hours. In its early stages, the Me-262's development was hindered by the scarcity of high-temperature alloys needed for turbine construction, forcing engineers to compromise on materials that could withstand only limited stress. Moreover, as the war intensified, industrial disruptions caused by Allied bombing made large-scale production increasingly difficult. The jet fighter's fate became tied not just to engineering success, but to Germany's diminishing industrial capacity and its leadership's inability to prioritize strategic projects effectively. The Me-262 thus represents both a pinnacle of wartime aeronautical achievement and a case study in the limitations of deploying groundbreaking technology under adverse strategic conditions. Its story begins as a bold vision to redefine aerial combat, but unfolds amid a series of technical, logistical, and political battles that would ultimately shape how and when this revolutionary aircraft entered the war. The prototype and testing phase of the Me-262 was marked by both remarkable technical achievements and persistent engineering hurdles. The first prototype, designated the V1, initially took to the air in April 1941, but notably, this flight was conducted using a conventional Junkers Jumo 210 piston engine mounted in the nose. This was a necessity due to delays in the development of the intended BMW 003 turbojets, which were not yet ready for flight. The early test flights focused on validating the aerodynamic design, stability, and control surfaces, ensuring that the airframe could handle the stresses anticipated at jet speeds. By mid-1942, the first turbojet-powered trials began, although they were plagued by reliability issues. The BMW 003 engines failed repeatedly, forcing engineers to switch to the Junkers Jumo 004 design, which proved more robust but still far from trouble-free. On 18 July 1942, the Me-262 made its first fully jet-powered flight, piloted by Fritz Wendel. Test pilots immediately noted the extraordinary acceleration and smoothness compared to piston engine fighters. However, the new engines were extremely sensitive to throttle inputs, and rapid acceleration could cause compressor stalls or even complete engine failure. This required pilots to adapt to a more deliberate and cautious flying style, especially during takeoff and landing, Further testing revealed additional challenges. The tricycle landing gear, though advantageous for ground handling, needed reinforcement to cope with the aircraft's higher takeoff speeds and heavier loads. Braking systems also required improvement to manage the rapid deceleration from jet-powered landings. Engineers experimented with minor wing sweep adjustments and control surface refinements to ensure stability at transonic speeds, as compressibility effects began to influence handling near the aircraft's performance limits. Armament trials began in earnest in 1943 with the Me-262's nose-mounted 30mm Mk-108 cannons proving capable of destroying heavy bombers with a minimal number of hits. However, the high rate of recoil presented challenges for maintaining firing accuracy at extreme speeds. Additional testing was carried out to evaluate the aircraft's potential as a fighter bomber, in line with Hitler's insistence that it serve in a multi-role capacity. This led to the inclusion of hardpoints for bombs beneath the fuselage, though this adaptation compromised performance and conflicted with the Luftwaffe's original goal of creating a dedicated high-speed interceptor. Flight trials were conducted at multiple locations, including Augsburg and Rechlin, with combat-experienced Luftwaffe pilots brought in to evaluate the aircraft. Their reports were generally positive about the Me-262's speed and climb rate, but highlighted the steep learning curve associated with jet engine management and the need for specialized training. The aircraft's top speed of over 850 km per hour outclassed anything in the Allied arsenal, but its engine's fragility and short service life meant operational readiness would remain a constant concern. By the end of the testing phase, the Me-262 had proven its potential as a revolutionary combat aircraft, but it was also clear that its success in the field would depend as much on pilot adaptation and maintenance discipline as on its groundbreaking technology. The transition from prototype to production was approved, but it would unfold under the strain of mounting Allied pressure and dwindling German resources, shaping the nature of its eventual deployment. The Me-262 entered operational service in mid-1944, a point by which Germany's strategic situation had deteriorated significantly. The first units to receive the aircraft were not frontline squadrons, but specialized formations tasked with developing appropriate tactics and training methods. Erprobungskommando 262, formed in April 1944 under the command of Hauptmann Werner Thierfelder, was charged with introducing the jet to combat conditions. Early flights focused on intercepting Allied reconnaissance aircraft, a task for which the Me-262's speed was uniquely suited. These initial engagements demonstrated its overwhelming advantage in level flight and climbing pursuit, though takeoff and landing phases left it vulnerable to enemy fighters patrolling near its airfields. By the summer, operational deployment expanded with the formation of Kommando Nowotny, named for ace pilot Major Walter Nowotny. This unit's mission was to intercept Allied bomber streams over Germany and, in doing so, test the Me-262's capabilities in massed air combat. The results were mixed. On the one hand, pilots reported that the jet could close on Allied B-17 and B-24 formations with unprecedented speed, often delivering devastating attacks before escort fighters could react. The Mk-108 cannons, with their high-caliber shells, could down a heavy bomber with just a few hits. On the other hand, the Me-262's vulnerability during takeoff and landing proved to be a persistent problem. Allied fighters, aware of the aircraft's limited acceleration on the ground, began loitering near known jet bases, ambushing Me-262s before they reached combat speed. Operational constraints also emerged from logistical and mechanical issues. The Jumo 004 engines, though more reliable than the BMW 003, still had an average service life of only 25 to 50 hours before requiring replacement. Fuel shortages further restricted training and mission frequency, while a shortage of spare parts meant grounded aircraft were a common sight at jet bases. Moreover, the Luftwaffe struggled to adapt its doctrine quickly enough to exploit the Me-262's capabilities fully. Traditional dogfighting tactics were ill-suited for the jet, which excelled in high-speed boom and zoom attacks rather than prolonged turning engagements. Despite these challenges, the aircraft scored notable successes. Pilots such as Franz Schall and Georg Peter Ader achieved multiple kills in single sorties, often outpacing Allied escorts entirely. The psychological effect on Allied crews was significant. Bomber crews referred to the Me-262 as a near-invincible blowtorch that could appear suddenly, inflict heavy losses, and disappear before effective counterfire could be organized. However, these successes came too late to alter the strategic balance. In an attempt to adapt the aircraft to multiple roles, the Luftwaffe also began using the Me-262 in fighter-bomber missions, designated as the A-2A variant. These missions were intended to disrupt advancing Allied ground forces, particularly during the late stages of the war in France and during the Ardennes offensive. The additional bomb load, however, reduced speed and agility, making the jet more vulnerable to interception. Luftwaffe pilots criticized this shift in operational use, seeing it as a waste of the Me-262's potential as a pure interceptor at a time when the defense of German airspace was critical. By late 1944, the Me-262 was no longer a secret, and Allied intelligence had begun to anticipate its use. This awareness, coupled with targeted airfield attacks, limited the aircraft's operational impact despite its technical superiority. Even so, its presence marked the dawn of a new era in aerial combat, demonstrating to both friend and foe that piston-engine fighters were approaching obsolescence. The combat deployment of the Me-262 intensified in early 1945 as the Luftwaffe reorganized its jet fighter forces into Jagdgeschwader 7, JG-7, the first operational jet fighter wing in history. Under the command of Oberst Johannes Steinhoff, JG-7 was tasked primarily with intercepting Allied bomber formations over Germany. The unit was structured to maximize the aircraft's strengths, high-speed interception runs, quick disengagement, and rearming for repeated sorties. But the practical realities of the war hindered these plans. Fuel shortages, airfield bombings, and the scarcity of spare engines drastically limited sortie numbers. Even at its peak strength, JG-7 rarely managed to field more than a fraction of its nominal aircraft complement for any given operation. In its intended role as a bomber-destroyer, the Me-262 proved lethal. On March 18, 1945, during one of its largest coordinated jet attacks, JG-7 engaged a massive formation of over 1,000 Allied bombers and escorts targeting Berlin. Despite being outnumbered, the Me-262 pilots managed to shoot down approximately a dozen bombers and several fighters in a single engagement. These attacks demonstrated that in concentrated numbers, the Me-262 could penetrate escort screens, strike deep into bomber formations, and retreat before the enemy could effectively respond. However, such large-scale operations were rare due to the worsening logistical situation. Tactically, Me-262 pilots refined their interception techniques, favoring slashing attacks from above and behind at speeds that made it nearly impossible for piston-engine fighters to follow. Allied pilots flying P-51 Mustangs or P-47 Thunderbolts found it nearly futile to pursue a retreating jet. Instead, they focused on ambushes during the Me-262's vulnerable takeoff and landing phases. To counter this, the Luftwaffe implemented protective measures, such as heavily armed flak positions near jet runways and the use of Bf-109s and FW-190s as airfield defenders, to shield the jets during their most dangerous moments. In parallel, the Luftwaffe attempted to adapt the Me-262 for the fighter-bomber role to support ground operations, particularly in the defense of the collapsing Western Front. The A-2A Sturmvogel variant, equipped with bomb racks for two 250 kilos bombs, was deployed in quick strike missions against Allied bridgeheads, supply depots, and troop concentrations. While the aircraft's speed allowed it to evade many anti-aircraft defenses, carrying bombs significantly reduced its maneuverability and acceleration, negating much of its performance advantage. These missions also exposed the aircraft to greater risk, and many Luftwaffe pilots considered them an inefficient use of such advanced technology when air defense remained the most pressing need. The Luftwaffe also began experimenting with new weapon configurations to increase the Me-262's destructive potential. Trials included the installation of R-4M unguided air-to-air rockets, which allowed a pilot to fire a devastating salvo into a bomber formation without closing to cannon range. This innovation increased lethality while minimizing exposure to defensive gunfire, and late-war combat reports suggest it was highly effective when used. However, limited production and the chaotic state of German industry in 1945 meant that only a small number of aircraft received the modification. By the final months of the war, the Me-262 was caught in a paradox. It was the most advanced fighter in the world, yet it was deployed in insufficient numbers, too late, and in an environment where Germany's strategic position was already irreversibly compromised. Allied air superiority, coupled with relentless bombing of production facilities and airfields, ensured that the Me-262 could not change the outcome of the air war. Nevertheless, every operational sortie reinforced the aircraft's revolutionary status, showing the potential of jet propulsion and shaping the strategic thinking of all major post-war air forces. Several distinct variants of the Me-262 emerged during its short but influential service life, each tailored to address specific operational requirements or to experiment with new roles. The base fighter model, the Me-262A-1A, was optimized for air superiority and bomber interception, armed with 4 Mk-108 30mm cannons and in some cases supplemented by R-4M rockets. This configuration remained the backbone of the jet's combat operations and set the template for high-speed interception tactics that would influence post-war jet fighter design. For fighter-bomber duties, the Me-262A-2A Sturmvogel variant was produced. It featured reinforced hardpoints under the fuselage to carry 2 SC-250 bombs, enabling it to strike ground targets at speeds that made interception by Allied fighters nearly impossible. However, this capability came at the cost of reduced climb rate, range, and agility. Luftwaffe leadership remained divided over the bomber variant's value, especially given the pressing need for air defense late in the war. Another important adaptation was the Me-262B-1A, a two-seat trainer designed to accelerate pilot conversion to jet operations. Transitioning from piston engine fighters to jets required new training protocols, especially concerning throttle control to avoid compressor stalls and the higher approach speeds during landings. The B-1A retained armament, allowing it to serve in limited combat roles if necessary. This dual-seat design later became the basis for a night fighter variant, the Me-262B-1A-U1, equipped with Liechtenstein SN2 radar and armed with both cannons and, in some cases, upward-firing Schrage music installations. These night fighters achieved some success against RAF Mosquitoes and bombers, but production numbers were minimal due to component shortages. Plans for further development extended into several ambitious prototypes. The Me-262C series explored high-speed interceptor concepts, including rocket-assisted takeoff and climb for rapid interception of high-altitude targets. The Me-262C-1A Heimatschützer was fitted with a Walter HWK-109509 rocket motor in the tail, supplementing the jet engines to achieve extreme climb rates. Another concept, the Me-262HG Hochgeschwindigkeit or high-speed series, experimented with swept wings and other aerodynamic refinements intended to push performance beyond Mach 0.9. These prototypes foreshadowed design principles that would become standard in second-generation jet fighters of the 1950s. Outside Germany, the Me-262's influence was immediate. After the war, surviving aircraft were captured, tested, and studied by the Allies. The United States, United Kingdom, and Soviet Union each examined the design in depth, reverse engineering its features to accelerate their own jet fighter programs. Soviet designers drew on Me-262 research for the early MiG series, while in the US, lessons from the jet-informed projects such as the F-86 Sabre. Had Germany's industrial situation been stable enough to produce specialized sub-variants in large numbers, the Me-262 might have fielded purpose-built reconnaissance aircraft, advanced bomber interceptors, and even early guided missile carriers. In reality, most planned versions remained on paper or in prototype form, as the Reich's war effort collapsed. Still, the aircraft's ability to inspire post-war innovations solidified its place not just as a groundbreaking combat machine, but as a direct ancestor to the jet fighters that would dominate Cold War air combat. The global impact of the Me-262 extended far beyond its limited wartime deployment, shaping the trajectory of jet fighter design and influencing military aviation doctrine for decades. Although it entered service too late and in too few numbers to alter the outcome of the Second World War, its performance demonstrated unequivocally that the future of air combat belonged to jet-powered aircraft. Allied air forces, which had entered the conflict with piston-engine fighters like the Spitfire and P-51 Mustang, now faced an aircraft capable of speeds in excess of 850 km/h, well beyond the operational limits of their own fighters. In the immediate post-war period, captured Me-262s became invaluable research assets. The United States tested several under the designation P-262, or with original German markings at Wright Field, subjecting them to detailed evaluations of flight characteristics, maintenance requirements, and engine performance. These tests directly inform the design philosophy behind the F-84 Thunderjet and F-86 Sabre, particularly in the adoption of swept-wing configurations for improved high-speed handling. Similarly, the Soviet Union studied Mi-262 examples acquired through Czechoslovakia, feeding critical data into the development of the MiG-9 and later MiG-15, which would emerge as a dominant fighter during the Korean War. Czechoslovakia itself continued production of the Mi-262 after the war under the Avia S-92 designation, using leftover airframes and engines. Although produced in small numbers, the S-92 and its two-seat trainer variant, the CS-92, served primarily as jet training platforms for the nascent Czechoslovak Air Force. Their operational use was limited, but they prolonged the active life of the design into the early 1950s. Culturally, the Mi-262 became a symbol of both technological daring and strategic failure. In aviation history circles, it is often discussed alongside projects like the V-2 rocket as part of Germany's late-war Wonder Weapons program. Impressive in concept but undermined by resource shortages, political interference, and the overwhelming industrial superiority of the Allies. Its image, sleek and predatory, has become an icon in museums, air shows, and historical documentaries. Surviving examples are preserved in institutions such as the Smithsonian's National Air and Space Museum, the Deutsches Museum in Munich, and the RAF Museum in London, where they remain among the most visited exhibits. In military thought, the M262 reinforced the idea that technological leaps could render existing doctrines obsolete almost overnight. Air defense strategies, previously based on interception by propeller-driven fighters, were reimagined to incorporate jets with superior speed and climb rates. The aircraft also highlighted the necessity of integrating new weapons into broader logistical and operational frameworks, something Germany failed to achieve under wartime pressure. Even today, the Mi-262 is studied not only as a historical artifact, but also as a case study in innovation under extreme conditions. It serves as a reminder that advanced design alone cannot secure victory. Without proper doctrine, pilot training, and industrial support, even the most revolutionary aircraft risks becoming a footnote in history. The Mi-262's legacy lies not in the battles it won, but in the future it foretold. A future in which air superiority would be defined by jet propulsion, aerodynamic efficiency, and the seamless integration of cutting-edge technology into combat strategy. Lesser-known chapters of the Mi-262 story reveal a range of experimental roles, unrealized upgrades, and specialized missions that never reached full potential but add depth to its historical footprint. Beyond its well-documented role as a high-speed interceptor, German engineers and Luftwaffe planners explored concepts that pushed the aircraft's adaptability far beyond initial intentions. One of the more unusual adaptations was the Mistel project, which paired a manned Mi-262 with an unmanned explosive-laden airframe, intended as a long-range precision strike platform against heavily defended targets. Although some prototypes were tested, the worsening war situation and fuel shortages meant these composite aircraft never entered operational use. Similarly, plans existed for a heavily armed bomber-destroyer variant equipped with upwards of 6 Mk-108 cannons designed to annihilate Allied bomber formations in a single pass. This version remained on paper due to weight concerns and engine limitations. Reconnaissance versions, designated Mi-262A1A-U3, carried cameras instead of heavy armament, allowing them to photograph Allied troop concentrations, industrial sites, and coastal defenses with minimal risk of interception. These missions were particularly valuable in 1944 and early 1945 as Germany sought intelligence for counteroffensives, though their strategic value was undermined by the Allies' overwhelming reconnaissance capabilities. An ambitious but short-lived plan involved adapting the Mi-262 as a jet night fighter, designated Mi-262B2A, with extended fuselage for radar equipment and a second crew member. While a small number of Mi-262B1A-U1 night fighters were completed and saw limited combat against RAF Mosquitoes and bombers, radar technology of the period was bulky and unreliable, restricting effectiveness. The concept hinted at the potential for a fully jet-powered night interception force, but Germany's collapsing industrial capacity prevented its realization. In addition to combat roles, the Mi-262 also participated in experimental testing. aerodynamic research flights examined wing shapes, control surface behavior at transonic speeds, and engine performance under various load conditions. Some captured Me-262s served as test platforms for jet engine endurance studies in the United States, helping engineers understand compressor blade fatigue, turbine material durability, and the effects of high-altitude operation on jet power plants. Plans for an advanced successor, sometimes referred to as the Me-262HG Hochgeschwindigkeit or high-speed Wandes series, incorporated more pronounced wing sweep and refined aerodynamics to approach supersonic flight. These designs were decades ahead in vision but never moved past wind tunnel models and partial prototypes. For veterans who flew the Me-262, recollections often blend awe with frustration, praising its speed and firepower while lamenting its mechanical fragility and the scarcity of fuel and spare parts. Many of these pilots understood they were participating in the dawn of a new era, even as they faced the certainty that it was too late to alter the war's outcome. These unseen chapters, half-finished projects, specialized variants, and experimental missions highlight the Me-262 not just as a weapon, but as a technological laboratory in the sky. In many ways, its greatest influence came not from what it achieved during wartime, but from what it promised for the future, inspiring generations of engineers to explore the boundaries of jet-powered flight. The Me-262's legacy after the war was shaped not only by its combat record, but by the way it was studied, copied, and adapted by victorious nations. When Germany capitulated in May 1945, dozens of intact airframes and even more partially completed units were seized by Allied forces. The United States, the Soviet Union, the United Kingdom, and France all conducted extensive evaluations of the jet, recognizing its significance as the first operational aircraft to combine swept wings, high subsonic performance, and turbojet propulsion. In the United States, the captured Me-262s were transported to Wright Field in Ohio for flight testing under the Operation Lusty program. American test pilots, including some who would later become prominent figures in post-war aviation development, reported that the aircraft handled well at high speeds but was prone to slow throttle response, a direct result of the early jet engine technology. Data gathered from these tests influenced the development of the F-86 Sabre, particularly in terms of wing sweep and aerodynamic efficiency. The Soviet Union also gained access to several Me-262 airframes, which were dismantled and reverse-engineered. The resulting studies fed into the creation of early Soviet jet fighters, notably the MiG-9, and indirectly contributed to the rapid progress toward the MiG-15. Soviet engineers noted the innovative but maintenance-intensive design of the Jumo 004 engines, and used the experience to refine their own turbojet manufacturing techniques. In the United Kingdom, the Royal Aircraft Establishment analyzed the Me-262's structural design, landing gear configuration, and flight stability. Although Britain already had its own jet projects underway, such as the Gloucester Meteor, the Me-262 provided valuable comparative data, especially in terms of combat-oriented jet design rather than experimental platforms. Post-war, the Czechoslovak Air Force became the only operator to use the Me-262 in service under its own markings. Producing the jet under the designation Avia S-92 single-seat and CS-92 two-seat trainer, Czechoslovakia built them from remaining German parts and partially completed airframes. While the type saw no combat in this role, it gave Czechoslovak pilots valuable jet experience in the early Cold War years. The Me-262's influence extended into aerospace engineering culture. Many of the German engineers involved in its design were brought into Allied service through programs like Operation Paperclip, where their expertise shaped the next generation of military and civilian jet aircraft. In this way, the Me-262 indirectly contributed to both NATO and Warsaw Pact aviation progress during the formative years of the Cold War. Today, surviving Me-262s are preserved in museums worldwide, from the Smithsonian National Air and Space Museum to the Deutsches Museum in Munich. In recent decades, a small number of reproduction aircraft have been constructed using modern materials and engines, allowing new generations to see the jet in flight. These replicas serve not only as historical artifacts, but as living demonstrations of the leap forward in aviation technology that the Me-262 represented. Its cultural impact also endures. The aircraft has appeared in countless documentaries, war films, and aviation histories, symbolizing both the promise and peril of revolutionary weapons technology. For aviation historians, the Me-262 remains a central case study in how innovation can be both groundbreaking and constrained by the industrial and strategic realities of its time. Beyond its well-documented history and influence, the Me-262 also has a lesser-known chapter involving experimental missions, unrealized variants, and ambitious projects that never left the prototype stage. These endeavors reveal the scope of German jet ambitions in the final years of the Second World War, and the extent to which the Me-262 was envisioned as more than a standard fighter. One of the most intriguing proposals was the Me-262 Hochgeschwindigkeitsbomber, high-speed bomber, configuration, sometimes referred to as the Schnellbomber variant. This version, ordered by Hitler himself in 1943, was intended to carry bombs internally and strike targets at high speed, outpacing enemy fighters. This decision to prioritize a bomber role over pure fighter deployment delayed the aircraft's introduction as a dedicated interceptor, a strategic choice often cited as a factor limiting its wartime impact. While some bomber-capable Me-262s did fly missions, they never achieved the decisive results envisioned, and many pilots considered the fighter-interceptor role far more suitable. Another experimental path involved the Heimatschützer, Homeland Defender concept, which paired the Me-262 with rocket-assisted takeoff units to enable rapid climbs and interception of high-altitude Allied bombers. Several prototypes were fitted with solid-fuel booster rockets, drastically improving takeoff performance, but these systems proved difficult to manage and dangerous to operate. Naval adaptation was also explored. Plans for a Me-262A2B carrier-capable version for the German aircraft carrier Graf Zeppelin were sketched but never advanced beyond paper due to the carrier's incomplete state and Germany's deteriorating war situation. Similarly, reconnaissance versions equipped with cameras instead of armament were tested, aiming to take advantage of the jet's speed for intelligence gathering. A few prototypes were also tested with heavy armament upgrades, including the installation of a single 50mm Mk214 cannon intended for bomber destruction. While the gun was devastating when it hit, its recoil, weight, and low rate of fire made the aircraft difficult to handle and unsuitable for regular combat missions. Even more ambitious were concepts for a Me-262HG, Hochgeschwindigkeit, high-speed series, incorporating improved aerodynamics, thinner wings, and more powerful engines to push speeds further into the transonic range. Some designs even featured a sharply swept tail and canopy modifications, reflecting early steps toward what would become post-war supersonic fighters. After the war, these incomplete programs became valuable blueprints for Allied research. Engineers in the United States, Britain, and the Soviet Union studied not only the operational Me-262 but also these unbuilt concepts, seeing them as potential starting points for next-generation designs. While most of these advanced variants never saw combat, they offer a glimpse of how far ahead German designers were thinking, often years beyond the technological and logistical capabilities of their wartime industry. For aviation historians, these what-if versions of the Me-262 remain an essential part of the aircraft's story, showing that it was not just a single revolutionary jet, but the foundation for an entire family of designs that could have reshaped aerial warfare had they been realized. The legacy of the Messerschmitt Me-262 is defined not only by its role as the world's first operational jet fighter, but also by the profound influence it exerted on post-war aviation and military doctrine. Despite its limited combat record, just over a year of operational use, the aircraft demonstrated beyond question that the jet age had arrived and that piston engine fighters were destined for obsolescence. In the immediate aftermath of the war, captured Me-262s became invaluable research tools for Allied powers. The United States transported several examples to testing facilities such as Wright Field, where engineers studied their airframes, engines, and aerodynamics. These evaluations directly informed the development of early American jets like the F-80 Shooting Star and later the F-86 Sabre. Similarly, the Soviet Union, which acquired airframes through Czechoslovakia, reverse-engineered components and design principles, accelerating the introduction of fighters like the MiG-9 and MiG-15. Even Britain, already working on the Gloucester Meteor, incorporated lessons from the Me-262's swept-wing research into later designs. Culturally, the aircraft became a symbol of both technological brilliance and strategic mismanagement. Its image, sleek, fast, and lethal, was embraced in post-war media and aviation literature, often depicted as a wonder weapon that might have altered the course of the air war had it been deployed earlier and in greater numbers. Yet historians consistently point to factors that limited its potential: chronic shortages of skilled pilots, fuel scarcity, the immaturity of early jet engines, and the diversion of resources into bomber variants. In military thinking, the Me-262 demonstrated that speed and climb performance could redefine air combat tactics. The traditional turning dogfight became less relevant, replaced by high-speed slashing attacks and energy management strategies. Air forces worldwide began rethinking interceptor roles, focusing on rapid climb to altitude, hit-and-run attacks, and coordinated ground control guidance. Tactics mirrored decades later in supersonic jet doctrine. Preserved examples of the Me-262 in museums today, such as those in the Smithsonian National Air and Space Museum, the Deutsches Museum, and the RAF Museum, serve as both engineering artifacts and reminders of wartime innovation under extreme conditions. In recent years, a small number of flying reproductions have been built using modern materials and engines, offering a rare chance to see the aircraft in flight and appreciate its design in motion. Ultimately, the Me-262's story is one of groundbreaking achievement constrained by the realities of its time. It proved that jet propulsion could revolutionize aerial warfare, but also showed that revolutionary technology alone could not guarantee strategic success. The lessons drawn from its development, deployment, and limitations shaped the trajectory of Cold War air power, ensuring that its influence extended far beyond the final battles of the Second World War.